All right, so here's another lunch break. Doing your homework. So this is solve graphically, state the solution space as an interval and inequality. So we're supposed to graph these two things and see where they intersect. So 2 times x minus 1 squared is going to go right 1, and then I can start drawing it. It has an initial slope of 2, and then I can start graphing it. But I'm going to be a little cautious about that yet. I'd kind of like to know some more values on this. If I'm going to solve graphically, I need to be 100% accurate in my graph. So an x is 3. That would create what, an 8? 3 minus 1 is 2. 2 squared is 4 times 2 is 8. So when x is 3, I get to be the point 8. Should be right up here. Then I can use my symmetry and get another good point. Need to have really good graphs when you're going to solve graphically. The other guy is 4x minus 4. So down 4, then rise 4, run 1. Rise 4. All right, cool. That's got two nice intersections. I had actually done this. When I made this problem up a long time ago, I actually thought it out. Good. Sometimes I don't. So there's the graph. I am supposed to determine where this line, see how that system works? It's asking where is the line less than or equal to the quadratic? Where is the line below the quadratic? That's what it's actually asking you. Where is the line below the quadratic or equal to the quadratic? No? It's actually two places. Here and here. There's two answers to that thing. So we answer these in terms of, I said where. Where would be x? X is domain. The answer to this is when x is less than or equal to 1. I'm including that equality symbol because we have it here. And when x is greater than or equal to 3. There's my two answers for it. That's as an inequality. As an interval, I would be looking at negative infinity to 1 unioned with 3 to infinity. There's one of these on your next test. Not in that aspect, but understanding the graph. Solve algebraically. Remember, you need a number line to test around critical values. Kids just love these. Going to shift that 28 over. Factor it. That's an easy one. What is that? Minus 4, minus 7. And we actually have here our critical values of x. X subscript c for critical value. Critical value is 4, and the critical value is 7. And then we just put these things on a number line. Put a 0 there, 1, 2, 3, 4. Nice good solid dot because I said I could be 4, 5, 6, 7. Nice good solid dot. And we're going to test around these things. I'm going to test left of the critical value 4. I'm going to test a 0. If I plug a 0 into that thing, it says 0 greater than or equal to negative 28, which is definitely true because it is. So I get to keep all of this space. I'm going to test something between 4 and 7. I'm just going to pick on 5. So if I plug a 5 into this thing, I'd have 25 minus 55, which is negative 30. Negative 30 greater than or equal to negative 28. That is most certainly false. I get to be none of this space. Then I'm going to test something to the right of 7, which would be 8. So if I plug an 8 into this thing, I'll have 64 minus 88, which is negative 24. And that is a true statement. So I get to be all this space. So my solutions here, if I like inequalities, are that x is less than or equal to 4, or x is greater than or equal to 7. If I like intervals, negative infinity to 4 with a bracket, union with 7 to infinity with a bracket on the 7. 37, also another one of these quadratics. Shift that 8x over. 3x squared plus 5, sorry, plus, do that again. 3x squared minus 8x plus 5 more than 0 now. Figure out my critical values here. I don't think it factors. Factors of 5? Yeah, it does. Maybe minus 5 minus 1 greater than 0. So my critical values here, if I use the cover-up rule, are 5/3 and 1. So a critical value is 5/3 and another critical value is 1. These will be open hold on your number line. 5/3 is somewhere between 1 and 2. Kind of a little space right there. We need to test something to the left. I'm going to test 0. If I plug in a 0 here, I would literally have 5 greater than 0, which is true. I need to test something in between. Something between 1 and 5/3 would be something like 4/3. So I'll write that out. I'm tired. I'll probably hit buttons on a calculator, to be honest with you. 3 times 4/3 squared plus 5 greater than 8 times 4/3. 16/9, 16/3. It's going to be 31/3 greater than 32/3. That's false. And now I need to test something over here, maybe a 2. So I was going to use a calculator, but I decided not to. If I plug in a 2, this becomes 17 on the left, and this becomes 16 on the right, and that's true. So I got to keep these regions of space. I didn't get to keep anything in between. So x is less than 1, or x is greater than 5/3. If I like intervals, I am negative infinity to negative 1, union with 5/3 to 1. A giant throws a midget from a 30-foot platform. The midget is traveling upwards at a rate of 128 feet per second squared. Write an equation modeling this situation. It's called y here. Y is negative 16t squared plus the initial velocity is 128 feet. And from a 30-foot tall platform, so plus 30. Simple enough. During what interval of time will the midget be above 80 feet? So if we're going to be above 80 feet, the equation itself is actually going to be bigger than 80. We'll have to one-side that thing. Actually, let me move everything to the left. I would like t squared to be positive. It would look like that. Not much you can do with this. I don't think it'll factor. I can pull a 2 from everything. That's about all I can do. Assuming my math is right, although that should be a plus 50, shouldn't it? So plus 25. Yeah, it's just ugly. There's nothing I can do with it. It's not going to clean up, look nice. So I'm going to have to do either complete the square of the quadratic formula on this piece right here, and I'll do the quadratic formula. That would be opposite b plus or minus the square root of b squared minus 4 times a, which is 8, times c, which is 25. Both pieces sitting over twice an 8. And one of these two values, my critical values, these are my critical values. I'd love to tell you I have an idea what 64 squared is, but I don't. I should though. I really should know what that is. 25 something, probably. Yeah. No, not 25 something. That'd be wrong. So that's what's in the radical. This is a real world problem. I'm just going to go ahead and take the square root of it. I'm not going to do a radical answer. 57.411. So the critical values are 64 plus or minus 57.411, both pieces over a 16, because twice an 8 is a 16. 64 over 16 is 4. And we got plus 57.411 over 16. One of my critical values is 7.59 seconds. The smaller critical value would be when I do the minus operation. 0.41 seconds. So what's actually going on here is the midget goes up and then they come down. And we're crossing this 80-foot barrier. We do it here when the time is 0.41, and we do it here when the time is 7.59. Literally, the time is stuck between these two things. That's one way of writing it. Another way of writing it is not with brackets, but with parentheses because it's above. I don't know why I used equality over here. The symbolism should have not been equal. It should have been a less than symbol. Should have not had equality. The other one is 0.41 to 7.59. There's that one. When will the midget die? The midget dies when he hits the ground, obviously. So 0 equals negative 16t squared plus 128t plus a 30. Man, there's the bell. The same thing as before, pull some numbers. You can still pull it 2. I don't think you can pull anything else. I'm going to pull the negative. I'll try and do this real quick before our 6th period actually comes in here. Negative 64. Sorry, that's minus. Positive 64 plus or minus square root of 64 squared minus 4 times a times c. Here it's a 15 this time, over twice a, twice an 8. What's in the radical this time? (3616). Square root of that bad boy being 60.13. So 64 plus or minus 60.13, both pieces over a 16, not an 18 like I'm writing. So 4 plus 60.13 is my most likely answer. It's the bigger number. Sorry, 4 plus 60.13 divided by 16. 7.76 seconds. There we go. There is the last. No, there's more. I still got a whole other page of this. Fairly long little homework assignment.